Artificial intelligence is advancing faster than any technology humanity has ever built. Models are scaling. Agents are becoming autonomous. Deployment is accelerating across every sector. From the outside, it looks like nothing can slow this down. But under the surface, a hard constraint has started to appear. Not in algorithms, not in data, not in talent, electricity. For years, the AI race was framed as a competition of intelligence. Who has the best model? Who has the most data? Who has the smartest researchers? That phase is ending. Today, the real bottleneck of artificial intelligence is power. Modern AI systems are not lightweight software tools. They are industrial machines. Training and running large models requires massive parallel computation. Tens of thousands of GPUs operating continuously. Complex cooling systems running non-stop. Redundant power infrastructure to avoid even seconds of downtime. A single large AI data center can now consume hundreds of megawatts of electricity. That is not a metaphor. That is more power than many cities. And this is already happening. Facilities operated or commissioned by companies like Microsoft, Google, and Amazon are pushing electrical grids to their limits. In some regions, utilities are struggling to approve new connections. In others, data center projects are delayed not by regulation, but by lack of available power. For the first time, artificial intelligence is colliding with physical reality. For decades, software progress felt almost detached from the material world. Code scaled faster than factories. Ideas moved faster than infrastructure. AI breaks that illusion. Artificial intelligence turns computation into a raw resource problem. And raw resources are never infinite. Electricity must be generated, transported, stabilized, delivered continuously. AI systems cannot pause when the sun sets. They cannot slow down when the wind stops. They cannot tolerate unstable supply. This is why energy has quietly become a strategic AI asset. Not sustainability marketing, not political messaging, engineering necessity. Solar and wind are valuable but intermittent. Battery storage helps, but not at the scale required for continuous AI workloads. Natural gas introduces volatility and geopolitical risk, which leaves one option returning to the center of the discussion: nuclear power. Not because of ideology, not because of climate debates, because nuclear delivers exactly what AI requires: dense, stable, continuous energy. This is why nuclear projects that were politically frozen for decades are suddenly being reconsidered. Why small modular reactors are gaining attention. Why energy policy and AI policy are starting to merge. Tech companies are no longer thinking like software firms. They are thinking like infrastructure operators. The AI race is becoming an energy race. This also explains a shift happening at the geopolitical level. AI leadership is no longer just about research breakthroughs. It is about who can deploy at scale. Deployment requires power. Power requires infrastructure. Infrastructure takes time, capital, and political coordination. Countries with strong, centralized energy systems have an advantage. Countries with fragmented grids face friction. This is one reason China's AI strategy focuses less on abstract intelligence and more on integration. Factories, robotics, logistics, physical systems tied directly to energy availability. In contrast, much of the Western AI narrative is still framed around models and timelines. But models alone do not run the world. Electricity does. This shift changes the economics of AI entirely. For years, the marginal cost of software approached zero. AI reverses that trend. Every additional unit of intelligence now carries a real energy cost, a measurable electrical footprint, a physical price. This means AI growth will not be smooth. It will occur in bursts. Regions with surplus power will accelerate. Regions with constrained grids will stall. This is not speculation. It is already visible in where data centers are being built delayed, or canceled. It also means the future of AI will be uneven. Not everyone will have access to the same level of intelligence, not because of code, but because of watts. And this leads to a deeper realization. The future of artificial intelligence will not be decided in research papers. It will not be decided by benchmark scores. It will be decided by infrastructure, by power plants, by transmission lines, by cooling systems, by land use, by political approval for energy expansion. The intelligence explosion is constrained by physics, and physics does not negotiate. This does not mean AI progress will stop. It means it will become selective. The systems that survive and dominate will be the ones attached to reliable energy, the ones embedded into real infrastructure, the ones backed by states and corporations capable of building at scale. The age of frictionless intelligence is ending. The age of powered intelligence is beginning. And the next breakthrough in AI may not come from a lab. It may come from a power plant. This transmission ends here. The next one is already forming. Stay aware and subscribe to Remain in the Signal.